Dear students, Namaste and welcome back to a new mathematics session. The previous session we have discussed the concept of probability and we have solved first 12 questions from exercise 15.1. Hope it was clear for you all. In today's session we shall discuss the remaining problems from exercise 15.1. Let's move on to the topic. Let's begin with question number 13. A die is thrown once. Find the probability of getting a prime number, a number lying between 2 and 6, and an odd number. The three probabilities we have to calculate. A die is thrown once. As we know that die is a 6-faced cube and it is marked with numbers from 1 to 6. So that is what we have to understand first when we hear about the die. Die is a cube with 6 faces marked 1, 2, 3, 4, 5 or 6. Means when we roll the die, we will get any one of these one face up. Then here first question is, what is the probability of getting a prime number? So the possible outcomes what we are having is numbers 1, 2, 3, 4, 5 and 6. From here you have to choose the prime numbers. Prime numbers are 2, 3 and 5. So the prime numbers are 2, 3 and 5, means the total 3 numbers. 2, 3 and 5, there are 3 prime numbers out of 6. So the favorable outcome is 3, total outcome is 6. So the probability of getting a prime number is favorable outcome divided by total number of outcomes, that is 3 divided by 6. Here 3 is common in both numerator and denominator. When we cancel with 3, we will get the answer as 1 by 2. Next one is a number lying between 2 and 6. Here these are our numbers 1 to 6. This is our result. And from 1 to 6 we are asked to find out the probability of number lying between 2 and 6. The numbers between 2 and 6 are 3, 4 and 5. So here also there are 3 numbers. So our favorable outcome is 3. Total outcomes remains the same, that is 6. So the required probability, that is probability of getting a number between 2 and 6 is 3 divided by 6. Here also 3 is common in both numerator and denominator. When we cancel, we will get it as 1 by 2. Then the third question, an odd number. Here from 1 to 6, what are the odd numbers? That is what we have to check. 1, 3 and 5 are the odd numbers. When we consider these numbers from 1 to 6, 1, 3 and 5 are the odd numbers. Here also there are 3 numbers. So the favorable outcome is 3 and total outcome is 6. So probability of getting an odd number is equal to 3 divided by 6, that is equal to 1 divided by 2. Before going to the next question, let's discuss about deck of playing cards. In a deck of cards there are total 52 cards. Total 52 cards are there in a deck of cards. Here it is categorized into 4. The first one is spade. The symbol is like this. Second one is heart. The symbol goes this way. And third one is clubs. It looks like this. And the final one is diamond. The symbol is this one. So here 4 names are there: spade, heart, clubs and diamonds. And in these 4, spade and clubs are called black cards. Hearts and diamonds, these two together we call it as red cards. So black cards means spade and club, red card means heart and diamonds. And each category there are 13 cards, means A, 2, 3, 4, 5, 6, 7, 8, 9, 10, J, Q, K. Here 4 alphabets are there. Here A, J, Q, K. And these 3 cards, when you check, their faces are printed. So these 3 cards are called face cards. And number cards means numbers are printed. 2, 3, 4, 5, 6, 7, 8, 9, 10. These are called number cards. And all these 4 categories also, the division is same. Means 3 face cards. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 number cards. And 1 ace. That is what the division. In hearts also same thing. A, 2, 3 up to 10. Then again jack queen and king. And it is red in color, that is why it is called red card. And the clubs again black cards, the same division, A, then number cards 2 to 10 and face cards J, Q and K. And in case of diamonds also same thing, A, then number cards up to 10, then the face cards 3. So this is the division of deck of playing cards. So you must go through in detail this one, then only you will be able to solve the next type of questions which is asked in probability. If you summarize without the diagram, in a deck of cards there are 52 cards and it is categorized into 4: spade, club, diamond and heart. The spade and club together we call it as black card, and diamond and hearts together we call it as red cards. And each category there are 13 cards, and total 13 into 4 we have 52 cards. And the number of black cards, if you check, 13 plus 13 we have 26 black cards, and the number of red cards, if you check, 13 plus 13 here also 26. So in general, if you say total number of cards in a deck of cards is 52, and it is categorized into 26 black and 26 red, and each category there are 13 cards. And one more important point we have discussed before regarding the face cards: king, queen and jack, means K, Q and J printed cards are called the face cards. So in each category there are 3 face cards. So here it is divided into 4. So total number of face cards: in spade also 3 face cards, club also 3 are there, diamond also 3 face cards, and hearts also 3 face cards. So total 3 into 4 we have 12 face cards in a deck of cards. Next we shall discuss question number 14. The question is, one card is drawn from a well shuffled deck of 52 cards. Find the probability of getting a king of red color, a face card, a red face card, the jack of hearts, a spade, the queen of diamonds. So you must be well aware of the number of divisions in a deck of cards, then only you will be able to solve these questions, these 6 questions. So one card is drawn from a well shuffled deck of 52 cards. One deck of cards, there are 52 cards, it is mentioned here. Find the probability of getting a king of red color. So the total number of cards in a deck is 52. First question, a king of red color. So as we know that the deck of cards are categorized into 4 subdivisions, that is spade, heart, clubs and diamonds. And here it is asked a king of red color. King is having 4 in number. In hearts also king is there, in spade also king is there, clubs also king is there, and in diamonds also king is there. Here it is asked a king of red color. Red color in the sense these are the total number of kings in a deck of cards, and here red cards you have to check. So here this one is a red and this one is a red. So total 2 red cards, means hearts king and diamond king only red cards. So 2 red cards are there, red king cards are there. So probability of getting a king of red color is 2 divided by total number of outcome. Total number of outcome we have 52. So here 2 and 52 we can cancel, it is 1 by 26. Next is a face card. We have discussed very clearly this one, a face card, in the previous slide. So probability of getting face card in the sense, so here face cards are there: king, queen and jack. These are the face cards. So in each category there are 4 face cards. So 4 into 3 we have 12 face cards are there. So this one we have discussed very clearly in the previous slide. So please go through it if you have doubt. So here the total 12 face cards are there. 12 divided by total number of outcomes 52. So 12 divided by 52. When we cancel with 4, here 4 3s are 12, 4 13s are 52. So 13 is in the denominator and 3 is in the numerator. 3 by 13. What we have done is we have cancelled 4. Then the third question, probability of getting a red face card. So now the face cards are available here. A red face cards you have to check. Red in color. Here 1, 2, this one is 3, this one is 4, and here it is red 5, and here it is another one 6. So total is 6 divided by total number of outcomes 52. What we have done is getting a red face card. So total 12 face cards are there in a deck of card. Out of that you have to choose the red colored one. 1, 2, 3, 4, 5 and 6. So 6 divided by total is 52. Here 2 we can cancel. 3 divided by 52, 2 cancelling means you will get 26. Then the fourth one, probability of getting the jack of hearts. So jack of hearts, jack in the sense J of hearts. Heart symbol is this one. So J of hearts in the sense we have only one J in hearts. So the total number of outcome is 52 and favorable outcome is in the numerator. Getting the jack of hearts. So these are the jack cards. 4 jack cards are there. In hearts there is only one jack. So 1 divided by 52. Total number of outcome is 52. Favorable outcome is 1. No cancellation. Then fifth one, probability of getting a spade. So here in a deck of card it is categorized into 4. One is spade, another one is hearts, another one is diamond and another one is clubs. So here getting a spade in the sense full division. There are 13 spades are there in a deck of card. So 13 divided by 52. Then next one is when you cancel here 13 in the numerator and denominator. 13 4s are 52. So 1 divided by 4 is the answer. Next is probability of the queen of diamonds, getting a queen of diamonds. Here queen of diamond in the sense this is the one. So queen, 4 queens are there, but in diamond there is only one queen. So favorable outcome is 1, total outcome is 52. No cancellation, let it be the same. 1 divided by 52. Move on to the 15th question. 5 cards, the 10, jack, queen, king and ace of diamonds are well shuffled in their face downwards. One card is then picked up at random. First question, what is the probability that the card is the queen? Second question, if the queen is drawn and put aside, what is the probability that the second card picked up is an ace or a queen? So let's go through the question once again. Only 5 cards are there. 10, jack, queen, king and ace of diamonds. Category is here diamonds. And number 10 card is there. J is there, Q is there, K is there, A is there. Are well shuffled with their face downwards. One card is then picked up at random. One card you are choosing after shuffling. What is the probability that the card is the queen? That is what the first question. And second, there are some conditions that we will discuss while explaining this second question. So first one, when we check, there are 5 cards. 10, jack, queen, king and ace. And here probability of getting a queen. Out of these 5 there is only one queen, that is this one, Q. So 1 divided by 5. Because total 5 cards are there, queen is only 1. So favorable outcome is 1 because that is the queen. 1 divided by total is 5. 1 by 5 is the probability. Next, if the queen card is put aside from 5 cards, then there will be 4 cards left. As per the question, if the queen is drawn and put aside, you are taking a queen and just keeping it away. What is the probability that the second card picked up is an ace or a queen? So here there are 5 cards and from here you have taken one queen and you are not keeping it back, you are taken away. And now balance there are only 4 cards. Queen is not there because you have taken that queen. So probability of getting an ace is there are only 4 cards left because queen you have taken in the first part and you have taken away and you did not keep it back. So we have only 4 cards left. So getting an ace in the sense there is only one A. So 1 divided by total is changing because total we are having only 4. One card you have taken away but you did not keep it back. So probability of getting an ace is 1 by 4. Next is probability of getting a queen. Probability of getting a queen in the sense in the second time or in the second question time you did not keep the Q back. Q card you did not keep it back because you have taken in the first category or first part while doing, then you did not keep it back. That means queen is missing. But in the second question it is asked probability of getting a queen means there is no queen here, already you have taken away. So the probability is 0 by total number of outcome is 4. Favorable outcome is 0 because no queen is available because you have taken away. There are only 4 cards but queen is not there. So 0 divided by total number of outcome 4, that is equal to 0. Or simply directly you can write the probability 0 because queen is not there, so it is considered as an impossible event. Directly we can write the probability 0. Why queen is not there? In the sense, in the first category while solving time there was a question, you have taken a queen, means you have taken the queen and you did not replace it back. Because of that, queen is not there the second time. So the probability of getting a queen is 0. Move on to the 16th question. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Determine the probability that the pen taken out is a good one. Let's go through the question again. 12 defective pens are accidentally mixed with 132 good ones. Now altogether it is mixed up. Out of that total number of pens, 12 are defective and 132 are good ones. So it is not merely just look and say that this is good or this is defective. It is not possible. One pen taken out at random from this lot means these two are now mixed up. From this group you are taking one pen at random. What is the probability that the pen taken out is a good one? That is what the question. So first of all, number of defective pens, it is given to us 12. Number of good pens we have got 132. For writing the probability we need the total number. So the total number of pens is 12 and 132 we have to add. You will get as 144. So this is our total number of pens. Question is, determine the probability that the pen taken out is a good one. So here there are 132 good pens are there. So your favorable outcome is 132. So probability of getting a good pen is equal to favorable one is 132 and total is 144. Probability formula, let's recall it. Favorable number of outcome divided by total number of outcomes. So 132 divided by 144. So here when you cancel here with 12, you will get it as 11 times because 132 when you cancel 12, 1 12s are 12 and balance there is 1 out of 13, again 2, so 12 one time, so 11, and 144 if you cancel with 12 times it will go because 12 into 12 is 144. So 11 divided by 12 is the required probability. Next we shall discuss question number 17. The question is, a lot of 20 bulbs contain 4 defective ones. One bulb is drawn at random from the lot. What is the probability that this bulb is defective? Suppose the bulb drawn in 1 is not defective and is not replaced. Now one bulb is drawn at random from the rest. What is the probability that this bulb is not defective? Here two parts are there. A lot of 20 bulbs contain 4 defective ones. So 4 defective ones, so total 20 bulbs are there, means 16 good ones. One bulb is drawn at random from the lot. What is the probability that the bulb is defective? It is a direct question. So let's solve that question first. Total number of bulbs we have 20 and defective ones are given to you 4. Question is direct. What is the probability that this bulb is defective if you have taken one bulb? Here favorable one is given to us, defective bulbs, because that is what the question. What is the probability that this bulb is defective? So defective bulb is the favorable one. So numerator there is 4 divided by total number of outcomes 20. So probability of getting a defective bulb is equal to favorable outcome divided by total outcome. Favorable one is 4. 4 divided by 20. Direct cancellation can be done with 4. 1 divided by 5 is the answer because 4 and 20 we can cancel 5 times. Next, second part. Suppose the bulb drawn in 1 is not defective and is not replaced. You have taken one bulb in the first part and in the second part it is given to us it is not defective, means good one. One good bulb you are getting. And it is not replaced, means you are taken away that bulb. Now one bulb is drawn at random from the rest. So balance there are only 19 bulbs. And what is the probability that this bulb is not defective? That is what the question. So a little bit of thinking we need to do here. Since, as we have explained here, since the number of defective bulbs was 4 out of 20, the number of non-defective means good bulbs, 20 minus 4, that is 16. And that, as per your condition, you are taking that bulb that is not defective one and you are not replacing it, means you are taking it away. Means 16 good bulbs are there. Out of 16 only you are choosing one in the first category or in the first question. You are not keeping it back. Means second question while solving, when you are taking the second bulb, what will happen is one number will be reduced. So the number of non-defective bulbs left is 16 minus 1. You have taken 1 already. So 16 minus 1 is equal to 15 because you are not replacing the bulb you have taken. You have taken a good bulb, not bulb. You have taken a good bulb in the first time and you did not replaced. Because of that, one number will be reduced. Total 16 good bulbs are there. Out of 16, one going means 15 balance. So here the question is, what is the probability that this bulb is not defective? So we are having not defective bulbs 15. So probability of getting a non-defective bulb is, our favorable outcome is 15 and the total outcome is 19 because total 20 was there in the first case and we have taken one good bulb and we have not replaced. So because of that, 20 minus 1, the total is changing to 90. So required probability is 15 by 19. Next we shall discuss question number 18. A box contains 90 discs which are numbered from 1 to 90. If one disc is drawn at random from the box, find the probability that it bears a 2-digit number, a perfect square number, a number divisible by 5. It's a very simple question. Only what you need to do is just find out the total number of outcomes and find out the favorable number of outcomes. If these two numbers are there, means we can just write the fraction. That fraction will be the required probability. Here a box contains 90 discs. Numbered from 1 to 90 means each disk is numbered from 1 to 90 means total there are 90 outcomes because there are 90 disks. So total number of outcomes 90. Let it be there in your mind. Then we will go for favorable outcome calculation. A 2-digit number. Numbers from 1 to 90 is marked. From here 2-digit numbers means it starts from 10. So 2-digit number starts from 10 to 90. So let's check how many numbers are there between 10 and 90 both inclusive. So 10 to 90 means we can remove 10 first. Then 11 onwards we can start counting. 11 to 20 we have 10. Then 21 to 30 we have another 10. Like that when you count multiples of 10 up to 90 you will get 80 numbers. And we have removed 10 first. So 80 plus 1. That removed 10 number is 1. So 80 plus 1 is 81 numbers. So total numbers between 10 and 90, 81 numbers. So you can use your own logic to calculate, not necessarily to write and count. So 81 numbers between 80 and 90. So our favorable outcome is ready here. Total is 90. So probability of getting a 2-digit number is favorable number divided by total number. So 81 divided by 90. Next one, perfect square numbers. So here between 10 and 90, perfect square numbers, sorry, not between 10 and 90, between 1 and 90. This is our question. Between 1 and 90, how many perfect square numbers are there? Perfect square numbers means a number multiplying by itself. So here 1 is a perfect square, 4 is a perfect square, 9, 16, 25, 36, 49, 64, 81. Up to 90, we have the previous square number is 81. So total 1, 2, 3, 4, 5, 6, 7, 8, 9. So favorable outcome is 9 and the total outcome is 90. So we can write the probability getting a perfect square number is 9 divided by 90. That is 1 divided by 10. You can cancel and write. Next is question number 3, a number divisible by 5. So from 1 to 90, which are the numbers divisible by 5? In the sense you can just write the multiples of 5. So 5, 10, 15, 20, etc. up to 90. When you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So favorable number of outcome is 18 divided by total number of outcome is 90. So 18 by 90. When you cancel, you will get 1 divided by 5. When you cancel 18, you will get denominator 5. So 1 by 5 is the required probability. Move on to question number 19. A child has a die whose 6 faces show the letters as given below: A, B, C, D, E and A. Previously we have learned that in a die 6 faces are there. It is marked numbers from 1 to 6. But here instead of numbers the letters are marked A, B, C, D, E and A. The die is thrown once. What is the probability of getting A? Another one is D. So here total number of outcomes we have to check. Very simple question. Total number of outcome in the sense there are 6 letters are marked. So total number of outcome is 6. Favorable outcome means question you have to check. Probability of getting an A. Getting A in the sense how many A's are there you have to check. Here 1A, here 1A. So total 2A. So favorable one is 2, total one is 6. So 2 divided by 6. If you want to cancel, you can cancel and write. Second one, probability of getting a D. You have to check how many D's are there. Here only 1 D is there out of 6. Probability is 1 divided by 6. Move on to question number 20. Suppose you drop a die at random on the rectangular region shown in figure. What is the probability that it will land inside the circle with a diameter 1 meter? The experiment what you are doing is you drop a die at random on the rectangular region shown in the figure. There is a figure, rectangular region length is 3 meter and breadth is 2 meter. You are dropping a die inside this rectangular region, and what is the probability that it will land inside the circle with a diameter 1? So you have to find out the probability of landing that particular die inside this circle. Diameter is 1 meter, means the radius we can say 1 by 2, half. Okay, 1 by 2 meter. So it's quite simple. First of all, we have to calculate the area of rectangle, because in this area only you are going to drop the die. So we have to find out that area, rectangular portion area, length into breadth, that is 3 into 2 is equal to 6 meter square. Then your favorable one is question. What is the probability that the die will land inside this circle? So you have to find out the area of the circle. Area of the circle is pi r square. So pi into r we have 1 by 2. So 1 by 2 square. That is 1 by 2 square means 1 square is 1, 2 square is 4. So pi into 1 is 1. Sorry, pi into 1 is pi, divided by 2 square is 4. So pi by 4 meter square. So your favorable one is pi by 4 meter square. Favorable one in the sense the question. What is the probability that it will land inside the circle? So inside the circle in the sense this much area is your favorable one. And your total area is this one, area of rectangle. So the probability of the die drops inside the circle is pi by 4 means favorable one divided by the total. Favorable outcome divided by the total outcome. Favorable outcome is pi by 4 divided by the total outcome is 6. So what you have to do is pi by 4 denominator you can make it to multiplication. Division you can change to multiplication. Denominator you can take the reciprocal 1 by 6. 6 is there. Since the division changed to multiplication, denominator will take the reciprocal form. So pi by 4 into 1 by 6. So pi into 1 is pi, 6 into 4 is 24. So pi by 24 is the required probability. Move on to question number 21. A lot consists of 144 ball pens, of which 20 are defective and the others are good. Now you will buy a pen if it is good, but will not buy it if it is defective. The shopkeeper draws one pen at random and gives it to her. What is the probability that she will buy it? Second one, she will not buy it. So the condition what is explained in the question, you must be very clear about it. A lot consists of 144 ball pens, of which 20 are defective and others are good. Total 144 ball pens are there. Out of the 144, 20 are defective. It is mixed up. So out of 144, 20 are defective. And Nauri will buy a pen only if it is good. So if it is defective, she will not buy. So the shopkeeper is taking one pen at random. It may be defective or maybe good one, we don't know, and gives it to her. The pen is giving to the customer, Nauri. What is the probability that she will buy it? She will buy it in the sense, in the condition it is already explained when she will buy. If it is good only she will buy. So if she is buying means the pen is good. If she is not buying means the pen is not good. That is what the question says. So the total number of ball pens we have 144. Number of defective pens it is given to us 20. Number of good pens means 144 minus 20, that is 124. Here probability of getting a good pen. First question is she will buy it. Probability of she is buying the pen. In the sense she is buying means it is a good pen. What the shopkeeper is taking, it is a good pen. That is what we have to calculate. Probability of getting a good pen means number of good pens is our favorable one. So 124 divided by the total is 144. Then we can cancel here with 4. 3 4s are 12 and 1 4s are 1. So 31 in the numerator and 144 when you divide 36 will be getting. So 31 divided by 36, cancelling with the 4 here. Then she will not buy it. She will not buy it in the sense if the shopkeeper is giving a defective pen, she will not buy. So the question changed like this. The probability of getting a defective pen. Probability of getting a defective pen means there are favorable defective, that is 20. So 20 divided by 144, that is the probability. 20 is our favorable outcome, 144 is the total outcome. Here when we cancel with a 4, 5 4s are 20, so 5 divided by 36. 144 divided by 4, previously also we have cancelled 36. Same number we can write, 5 divided by 36. Next we shall discuss question number 22. 2 dice, 1 blue and 1 grey are thrown at the same time. Complete the following table. 2 dice means each die is having 6 faces, numbered 1 to 6. So 1 blue and 1 grey color dice are thrown at the same time. Here there is a table which is given to you, sum on 2 dice. Each die will be getting one number from 1 to 6, and after that you are adding those two numbers. Suppose first die throwing time you are getting one number, and second die throwing time also you are getting another number, and these two numbers sum you are doing, and it may be 2 because minimum number you get is 2. Minimum sum you get because minimum number on the die is 1. So 2 ones, if you get 1 plus 1 is 2. So minimum sum possibility is 2, and the maximum sum possibility is 12 because the maximum number available in the dice is 6. 6 plus 6 is 12. So some probabilities are mentioned here. Probability of event getting a sum 2 on the dice is 1 by 36, and here sum is 8 means the probability 8 by 36. Again sum 12, if you are getting, the probability is 1 by 36. We have to fill these empty boxes. So first of all, let's write all the outcomes when 2 dice are thrown. As we know, dice are numbered from 1 to 6. You can see these are the possible outcomes. Total 36 outcomes are there. Means first die 1, second die 1. Again first die 1 you are fixing. Second die 2, third, again second die 3, again second die 4, again second die 5, again second die 6. Then 2 you are fixing. First die 2, second die is 1, second die 2, second die 3, 4, 5, 6. Again 3 you are fixing. First die you are getting 3 and fixing it, 3. Then again second die is 1, second die 2, second die 3, 4, 5 and 6. Again 4, first die you are getting 4, you are fixing 4. Then second die 1, 2, 3, 4, 5, 6. Likewise last digit is 6. In the first die means possibilities 61, 62, 63, 64, 65, 66. So these are the possible outcomes when you drop 2 dice. Here total 36 numbers are there, 36 pairs are there, and here we are going to check the sum is 3, and from here which are the two numbers adding time we will get sum 3. That is what you have to check. Here you can see sum is 2. Sum is 2 means only 1 and 1. 1 plus 1 only 2. There is only one pair is available. No other pair is there. When you add you get 2. So there is only one pair out of 36. That's why it is written 1 by 36. Now getting 3 when you add these two, 1 2 and 2 1. There are 2 pairs are there. So 2 by 36 will be coming. Next is sum is 4. Sum is 4 in the sense you can see here 1 plus 3 4, 2 plus 2 4, 3 plus 1 4. These are the 3 pairs. So 3 by 36. Next sum is 5. 5 in the sense you can see 4, 1, 2, 3, 3, 2, 4, 1. 1, 2, 3, 4. So total 4 out of 36. Next is sum is 6. 6 in the sense this one. 1, 5, 2, 4, 3, 3, 4, 2, 5, 1. So total 5 out of 36. Next is sum is 7. Sum is 7 in the sense these are the numbers 1, 6, 2, 5, 3, 4, 4, 3, 5, 2, 6, 1. So total 1, 2, 3, 4, 5, 6. 6 by 36. Next again with 8. When you check here, 8 here there are 1, 2, 3, 4, 5. 5 by 36 it is mentioned. Then we are going with a 9. 9 means you can see here 3, 6, 9, 4, 5, 9, 5, 4, 9, 6, 3, 9. 1, 2, 3, 4. So 4 by 36. Again with the 10 if you go 1, 2, 3. 3 by 36. Again with 11 if you check, there are 2 pairs 5 and 6, 6 and 5, that is 2 by 11. And finally 6 and 6 adding them 12 will be getting only 1 pair, so 1 by 36. Now the column is filled. Next, a student argues that there are 11 possible outcomes 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. Therefore each of them has a probability 1 by 11. Do you agree with this argument? Justify your answer. Means each of them has the probability 1 by 11. There are 11 outcomes, because of that each of them are having probability 1 by 11. Actually if the probabilities are same, in the sense we can say they are equally likely, but here the probabilities are not same, it is not possible. So no, do not agree with the statement, as the probability of each of them can never be 1 by 11, as the sum are not equally likely. So all the sums are not equally likely, because of that 1 by 11 probability will not be coming. So the argument is wrong. So we are not going to agree with the argument. Next we shall discuss question number 23. A game consists of tossing a 1 rupee coin 3 times and noting its outcome each time. Hanif wins if all the tosses give the same result, 3 heads or 3 tails, and loses otherwise. Calculate the probability that Hanif will lose the game. So he is tossing a coin 3 times. Means when you toss a coin 1 time, you may get either head or tail. Here he is tossing 3 times. So he is considered as a winner if he gets 3 tail or 3 head. If something else coming, means if mixed up like 2 head and 1 tail, something mixed up coming, means he may say that we can say that he will lose the game. So here we have to find out the probability that Hanif will lose the game. So here Hanif is losing the game means probability of not getting 3 heads and 3 tails in all the 3 tosses. In all the 3 tosses he should get different things. So the outcomes we can write, the possible outcomes are either he may get first time head, second time head, third time also head, or first time tail, second time tail, third time tail, or first 2 time tail, third time head, first time tail, second time head, third time tail, first time head, second time tail, third time tail, first time tail, second time head, third time head, first time head, second time tail, third time head, first 2 times head, third time tail. So these are the 8 possible ways. 1, 2, 3, 4, 5, 6, 7, 8. So 8 possible ways means 2 outcomes are there when you are tossing 1 coin. 3 times you are doing. So 2 power 3, that is the way you are supposed to calculate the number. 2 power 3 is 8. So there are 8 outcomes. You must use your logic to write these values. For example, here 3h, 3 tail is written. That is quite simple. After that 1h. This 1h we can have 3 possibilities. This h you can keep at last. This h you can keep in the middle. This h you can keep in the beginning. Then 2h and 1 tail. Means this t you can keep again in the middle and in the last. So there are some logic. Each individual is having different logic. So just based on your logic you can learn how to write this one. Now probability of not getting 3 heads and 3 tails means these 2 will go. Probability of not getting 3 heads and 3 tail means these 2 head will not come, t will not come, all mixed up will be there. That means these 6. That is 6 divided by total 8. That is 3 divided by 4. 3 divided by 4 in the sense we are cancelling here 2. So 3 divided by 4. So Calculate the probability that Hanif will lose the game. Probability of Hanif is losing the game is 3 by 4. Next, we shall discuss question number 24. A die is thrown twice. What is the probability that 5 will not come up either time? Second question, 5 will come up at least once. Here a die is thrown twice. We have previously also done this question. Die throwing die. 2 dice are thrown at a time. Then the total number of outcomes or the elements what we get is from 1 1 to 6 6. We have explained before this one. Then here 5 will not come up either time. Means no 5 will be there. So let's mark the things which are not related with 5. So these are the green shaded elements. They are not having any 5 in that pair. So here 1 1 1 2 1 3 1 4 1 6, no 5s are there. When you check each row shaded portion, there is no 5 is available. So total here 1 2 3 4 5 5 into 5, total 25. 25 favorable outcome, total number of outcomes 36. That is the probability of 5 will not come on either time. But next question, 5 will come up at least once. Minimum 1 5 should be there. That is quite simple. See, unshaded ones you can check. In unshaded ones all there is 5. Minimum 1 5 is there. Here 2 5 also is there. That is not a problem. So total 1 2 3 4 5 6 7 8 9 10 11. So probability of 5 will come up at least once is 11 divided by 36, because unshaded one is 11. That is our favorable one. 11 divided by 36. Move on to the last question of this exercise. Which of the following arguments are correct and which are not correct? Give reasons for your answer. There are some arguments are given to you. 2 arguments are there. If 2 coins are tossed simultaneously, there are 3 possible outcomes. 2 heads, 2 tails, or 1 of each. Therefore, for each of these outcomes, the probability is 1 by 3. This is the first argument. Second one, if a die is thrown, there are 2 possible outcomes, an odd number or an even number. Therefore, the probability of getting an odd number is 1 by 2. So, there are 2 arguments are there. Please go through this one and try this one as homework. Dear students, today we have completed exercise 15.1 and I request all the students to go through all the questions independently in a sheet of paper, especially the deck of card problems and tossing 2 dice questions. And while solving, if you have any doubt, please note it and keep. We will discuss it during the discussion session. Thank you for watching.